So basically what the compiler is doing right now is it is letting you copy data from one type into another type. So मेरे पास डेटा है जो कि फ्लोट के अंदर है, वो उसको डबल में कॉपी करने दे रहा है. क्यों करने दे रहा है? बिकॉज कंपाइलर को पक्का पता है कुछ भी डेटा लॉस नहीं होगा. फ्लोट के अंदर कम मेमोरी होती है, उसको अगर तुम डेटा डबल में कॉपी कर रहे हो तो वो कॉपी करने दे देगा तुम्हें. इसको हम इम्प्लिसिट टाइप कास्टिंग कहते हैं. यू आर कास्टिंग वन काइंड ऑफ डेटा इनटू अनदर. हम टाइप चेंज कर रहे हैं उसकी. इम्प्लिसिटली अपने आप हो जाता है इसको. राइट, दिस इज हैपनिंग बाय इटसेल्फ. कंपाइलर हमारे लिए अपने आप कर देता है. ओके, so if you have 4 bytes of integer, you have 8 bytes of long. This is okay because this is less memory, this is more memory, you can copy stuff. But as soon as you will try doing the opposite, that is not going to be okay. Why? Because the compiler is worried that this might contain a very big integer which cannot be copied into this part, and we will end up losing some data. Okay, so the compiler, you can tell the compiler, so as I said, L is equal to I is absolutely okay. I is equals to L. I is equals to L. Just 1 second. Yeah, I is equals to L. This is not okay. But what you can actually do is, you can, the implicit work that compiler was doing, you can explicitly tell the compiler, no, I want to change this long into an integer and please let me do it. So what's going to happen in this case? In this case, half of this will get copied here. So if my long, let's say, had a number 100, so this 100 will be contained within these 4 bytes. It's a very small number, you don't need all the data, so this will all be 0. So if you try to copy this long into this integer, small integer, by explicitly typecasting, you will get perfectly the same data, no issues. But if you have a huge number here and you try to copy this here, you will get completely different number, because the data did not get fully copied, part of it got copied, and that's why you're getting some different number. Okay, so let's give that a try. But before you do that, I just want to point one more thing. Like in case of float, I was not able to do 4.2. Why? Because by default it was taking this to be a double. Right? By default it was taking this to be a double. Okay. Similarly, so when I had to put it, I was doing 4.2f. Similarly, when you want to do a long L is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 1, a number this big, we need to put a L at the end of the number. Because as soon as you will put a number something like this, the compiler will give you an error. Oh, this is too big a number to be stored into an integer, and the default 4 bytes that it wants to copy this number into, it will not be able to copy into that. The temporary location which we were creating to copy this number into, that is 4 bytes, and the compiler will not be able to copy this code, this data here. But if you say L, putting an L at the end tells the compiler, oh, the temporary location that you want to create, please take a long for that. Okay. Okay, so let's give it a try. So our C was A, I is equal to C plus 10, that makes it 107. But then we did I is equal to C, that made it I to be 97 again. Now your long L contains I. Let's print L and I. I'm going to remove all the other prints from above. Let's remove them for now. And if you run it, both of them have 97, as you would expect. As soon as you were trying to do this, what? I is equals to L, we were getting an error. The error is you cannot copy from a long to integer. But what you can actually do is you can force your compiler, no, I want to do it, please do it for me. Will you lose some data here? L contains a very small number, 97. So copying that into I is absolutely okay. If you will run it, you will still get exactly the same result, 97 and 97. But the issue is, if before copying into I make my L to be a very big number, right? So as soon as I'm doing this, I'm getting an error. Let's look at the error. It's saying this literal is out of integer range. This number that you have written is out of integer range, so we'll have to put a L at the end. Now this is okay, right? So this is a big number which is out of integer range. That means 4 bytes were not enough for this number. So our long, which is 8 bytes, would have, for this data, we would have consumed more than just these 4 bytes. So when you will copy this long into an integer, you will only copy a part of data. You are not copying this part, which is going to stay here. I'll just explain again. So our long has 8 bytes. Because this number is too big to be stored in integer, that means it is too big to be stored into 4 bytes, we will not be able to store it only in this part. So a part of the data will be stored here as well, on this side. And when you copy this into a 4-byte integer, only this part will get copied, so your data will not stay the same. It's going to change. Let's try. Let's see if that's really how it works. Let's run it. And we had this big integer. When I copy it into an int I, I'm getting actually a negative number. So why would you get a negative number? What does that mean? So we are getting a negative number. That basically means these 4 bytes which got copied, the first bit was 1. Because this first bit was 1, we are getting a negative number into an integer. ठीक है, so बिल्कुल इसी तरह से हम सब जगह पे काम कर सकते हैं. So for example, if you want char ABC to be I, right? We are getting an error because you are trying to copy 4 bytes into 2 bytes. But if you want, you can explicit typecast, no, do it for me, and the compiler will let you do it. It will work absolutely fine. Okay, so you need to understand which types will get implicitly typecast, and if they cannot be done implicitly, if you are planning to do it explicit typecast, what is the data loss that can happen in that case? Thank you.